Square root of the, which one's quadratic? The what? The stopping distance. So remember the speed was 20 miles per hour, 30 miles per hour, 40 miles per hour. It's that stopping distance that is quadratic. So let's look at it here. Roughly how much is being added?
3.
About 3. Roughly how much is being added?
4.
3.
It's still about 3.3, isn't it?
Oh, I said 3 plus 4.
So plus 3 plus 3.3 here plus 3.3 here plus 3.3, 3.4. Notice, is that pretty close to adding the same amount every time? Yeah, and it's data, it's not going to be perfect, and that's okay. So let's follow the directions for the next side of things. I do want you to notice it says apply some operations to the dependent variable that you think will linearize the data. Y'all approach it a different way, right? And so you would want to make a note to yourself that you just examine the rate of change. And based on examining the rate of change, you knew the data was approximately what? Right. Right? So choose one operation you think linearizes the data best. Let's actually, I didn't have y'all do this, but I do want to point this out because y'all identify quadratic, and so you ended up taking the square root. Let's look and see what would happen if we didn't take the square root. Give me another operation that I could do other than taking the square root.
Times.
Okay, so I get times 2. So variable stopping distance times 2. Is that adding the same amount every time? No. Okay, what about if I squared it? Let's look at that. So instead of times 2, let's square it. What does that look to you? Does it look like it's constantly adding the same amount every time? Went from 1700 to 7700 is about plus 6,000. Then it jumped up to 2,600 or 26,000. Yeah, that ain't linear. What about if I took, remember we said the natural log is an option. So ln of the stopping distance. So to go to 3.71 to 4.47 is about 0.7, right?
It's adding about 1.
But then when I look at 4.47 to 5.0,
No.
is that adding 0.7?
No.
No. So is it linear, or is it, does that linearize the data well? No. So I want you to notice, if you use the wrong operation, it's not going to make the data linear. Does that make sense? But what was it, right, when I look here at this question, what was it that told us when we took the square root? And so choose one operation you think linearizes the data best. What operation would we say? We use what operation?
Array change.
No, what operation? We use the square root. So why do you think that operation linearized the data? Because it's the inverse of a quadratic, and we just identified the fact that it's approximately quadratic. What else? What, when we took the square root, told us it was approximately linear? So write down those details, and then we'll talk about So again, we already said, why do we think this operation linearizes the data best? Well, because the square root is the inverse of a square. But how did you know that that operation had in fact transformed the data to be linear? What did we look at? The rate of change. I would make that note to myself. What did we see was happening in that linearized set of data? It was repeatedly adding,
23. No, 21.
I think it was about 3, wasn't it? And I would say approximately 3. But those are the things that we want to recognize of like, okay, so we should find some kind of constant additive rate of change. So for your next question, what other operations did you attempt to, what other operations did you use to attempt to linearize the data?
Squared.
Well, I mean, before y'all found it,
Oh.
y'all didn't, right? So just put NA, not applicable. Okay, so then why do you think other operations do not linearize the data as well as your final selection? So we ended up with square root very quickly. Why would other operations not linearize the data as well as the square root?
Because it's not the right inverse.
So it's not the inverse of the type of function. That's a huge thing to notice here, right? It was not the right inverse, or it wasn't an inverse of the type of function. You got all that information down, right, Keyshawn? So when we look at that question of why do you think other operations do not linearize the data as well? Again, because they are not, those operations are not the inverse of the type of function, or the operation of the type of function. Okay, so here's what I want us to pay attention to. Y'all have not actually gotten a model yet. Actually, y'all need to get the model. I need to update these instructions to make sure. Oh yeah, determine or predict a function that might model explain the relationship. So y'all haven't gotten your model yet, have you? Okay, so where are we gonna go to get the model? 2.3, woo, good job guys. Now, do y'all see the data there? Y'all see any data? So what are we gonna do to be able to graph our data?
Zoom.
You can zoom and zoom the data. So go to 2.3, zoom to that data.
It's a straight line.
Is it a straight line?
See,
So for some of us, there's no data. So we may need to be careful. We might need to check to see what's been graphed on there, or even put in the data ourselves. So what are we going to have to do to check to make sure we've graphed the correct thing, or that we can create a graph?
Menu.
Okay, so go to menu, then what?
Graph entry.
Graph entry / edit,
Scatter plot.
and scatter plot.
I don't know what to do for that.
Okay. Preston, I think this might be yours or somebody's. Okay, so we want S1. What are we going to put under X for the X variable? By the way, don't forget, how can you access the variables?
VAR.
VAR. So, hey Jakeem, you're missing out on important stuff. So go to VAR. What was the independent variable?
Speed.
Speed. What was the dependent? But pause for a second. So go ahead and do stopping distance, because I do want to see the difference. So go to stopping distance, hit enter. Now hit so I can see one data point now. What would I need to do to see the rest of the data points? Don't do anything yet. Just wait a second.
Zoom.
Zoom, not just zoom out. Zoom to data, right? So try to fit that trend line to that data for me. It is slightly curved. Try to watch what happens when Preston tries to fit his data. Do you see how that data is curved?
Mm-hmm.
Does anyone recognize what type of curve that might be? Be a parabola. Remember how this was a quadratic function earlier? And so it is a parabola. So instead of doing speed and stopping distance, let's go back to our graph. So hit menu and go back to graph entry / edit and scatter plot. Now, Preston, if I were you, I would scroll up to S1 and instead of stopping distance, I would change that to linearized. Does that make sense? So variable, linearized. So make sure you have speed and linearized there, because that should be a linear set of data. Uh-oh. What's he gonna have to do now? All that data's down at the bottom, I can barely see it.
Zoom out.
Zoom out? You think so?
Zoom in, zoom in.
I was saying, I'm trying to see data here, right? So let's zoom to our data. That looks pretty linear, doesn't it?
Yeah.
Now, Preston, I don't see a trend line. What do you think you need to do? Maybe make a new one. I will point out, so go to graph entry/edit. We're going to function now. Notice how you're on F2. Scroll up to F1. Any guesses what the slope should be for this function? 30. 30? Where are you getting 30 from? So, Preston, leave yours here for now. Caleb, can I get you to go back to 2.2? Anybody see a way that we could get what we think the slope might be or should be? Any guesses? Hey, no, you're good. Okay. Yeah, just throw that on the back.
Thank you
counter.
for letting me do it now.
No problem. We're trying to find the approximately what that slope should be, right?
Yeah.
Any guesses? How can we use the table to help us figure out the slope now? Go back to the basics. What do we know about slope? It is ready to change. What else do you need to know about slope, guys? Okay,
Thank you, Mr. King.
no problem. Change your y. Just roughly, what do we think?
Linearized about 3.3.
About 3.3 there. So maybe 3.3. What about the x?
Where's the X?
Yeah, where's the x? Caleb, go to the x. Right?
About 10, I think it was.
I think it was about 10. Keep going. That's not x.
It is.
One more to the left, bud.
We'll go to the left.
There we go. There's our x.
Yeah, like,
Yeah, change them by 10.
I could tell.
So what do we think that slope should be about?
30.
Divided by 10. Okay.
30.
Okay, I was saying, you know that if you hit the little calculator symbol here, it goes to the scratch pad, and you can do 3.3 divided by 10.
That's 0.33.
0.33. So 0.33, now hit escape, and it goes back to your document, right? So, Preston, try the slope of 0.33. Might have to adjust it from there, but that'll probably make it easier to see. So back to Preston's. I still don't see it. Preston, go back to your function. Go back. Anyone see the issue?
The Y?
The y-intercept, right?
Yeah.
We don't need a negative 70 in the y. Let's just try 0.33x. See if that gives us anything. Oh. We might want to change it just a hair, but transform that data, or transform that trend line. Make sure y'all get your trend lines in there as well. Using the calculator, know what we know about linear functions, create a trend line model, a linear model. Jakeem, you got your linear model? Do you have your linear model for your data?
Come on, this.
Yeah, so you got your equation in there?
I've been at this. For a while.
How you scroll up to F1?
You just hit the up button on the D-pad. Did you get there? Okay. I will point out, I would write down your equation where it says, now it is important to note, either right above that, I need to update this because it's,
I think I got different values.
Confidence.
Mine not looking like y'all.
so write out your equation roughly right here.
I don't think I had the right thing.
Let me see, here's the look at your scatter. So right there where it says now is important to note, write out your linear model off to the side there. Look at that, does that have linearized? No, not even close. you need, remember we talked about this, you need to change your scatter plot so that it's not speed and stopping distance, so that it's speed and linearized, right? See how it's right there? So you're gonna need to zoom to the data again. That's trace. Okay, now you can go to that. Now change it. Okay. You already have the trend line. Oh.
Yeah, it kind of just went.
So you need menu, no, the trend line's already there. Now go graph entry / edit, and you want function. What are you doing?
Where's it? You're ready.
No, don't get ready. You got 3.5 minutes left. Y'all gotta come on with it. Step up.
I just like to, be on class on time. It's always eager to learn more.
No, you're trying to get out of my class early. There you go, that's good.
Okay, no killing.
Okay. So, Caleb, what's the equation you have? F of x equals?
0.33x minus 0.57.
Everybody have something close to that?
I got it.
You got it? Anybody want to push on Caleb's response to maybe update anything important?
Oh,
That. Remember, there's a prediction. These values don't go perfectly through that. Now, this is where we're really going to pick up tomorrow, but I need you to write this down before we get started. It is important to note that the above model is only for the linearized data, but you actually transformed the dependent variable. Didn't you take the square root of the stopping distance?
Yes.
Yes? So with such models, it is more appropriate to write equations with the transformation algebraically applied to the dependent variable. So notice here how it's written as the cube root of y hat. How would we write this equation then? Using that,
The cube root of our y, which was speed.
would you write the cube root?
No, you write just cube, because it was quadratic.
Would it? No. But what did you do to linearize the data? Because remember, this is a linear model. What did you do to make the data linear?
I took the square root.
So not cube root, but we would do a square root of y hat. You could do the square root of, if you want to include the wording. And Caleb, I know you're not packing up right now.
I'm not.
You can do the square root of the stopping distance. I would probably just do y hat. But for Caleb, the square root of y hat is equal to 0.33x minus 0.571. Okay? And so again, you would each have a slightly different equation, but square root of y hat. And that's where you would, what you would want to write right here. And this is where we will pick up tomorrow. The rest of these should go by a little bit faster. But you need to keep in mind what we did to identify the type of function, how to linearize it, and things like that. So that's what I was about to show you. We actually didn't get as far as I thought we would. I would say hold off on the new terms. You could start on the linearizing data but we haven't really done inverse operations versus inverse functions yet. So maybe start on linearizing data, but I have included those old terms if you want to take a picture of that. And other than that, just working on completing any old assignments. If we got zeros for anything.
I ain't got no taste, that last test.
You just barely made that B, son.
That last test, you were technically
Some people had their highest test grade yet on that test. So it was not that hard. Someone didn't take the time to learn it well.
What's this?
Okay. The last
Wait, we
test.
said that. It was a 9-4?
Alright, have a great rest of your
Look,
day.
I passed government economics with an 80. That's all I care about.
Why? Why don't you care about my class,
I
Caleb?
do care about economics.
What you talking about?
Why?
Can we just take your class next year?
Say again.
Can we just take your class next year?